Hey people, welcome back. And in today's session, we are going to learn how do we calculate a sigma level of the process when the specification is higher is better. I hope you remember in my last session when I was explaining about the specification, I explained you about three type of specification. Either the specification is higher is better. Example like as production, maybe quality, maybe sales, maybe revenue, maybe customer satisfaction, and many more. So these were our specification is higher is better. We take any example. Suppose your customer satisfaction is your one of the parameter. I generate some data. Some people calculate NPS score and all. And let's say my scale, which I am using to calculate is 1:10. 1 to 10 scale I am using. And I'm generating some CSAT data for past few customers, and the data is ranging from, suppose data is ranging from maybe let's say minimum value we are expecting 5, and 5 is there, and it is going up to 10, which means I am taking 9 here as a value plus adding some random number on a scale of 0 to 1, and these random number will be created. So my customer satisfaction score is generated for, this is for last, let's say 25 data points I have generated for my 25 different customers. Basis on this data, I want to look as an overall, what is my customer satisfaction sigma level of my process is. So how do we calculate that? How to convert that into the percentage yield? How to convert that into the defect per million opportunities? This is what we are going to learn in today's session. So suppose minimum expected level, because your higher is better. So any customer satisfaction as higher is good. And suppose your minimum expectation of customer satisfaction is, let's say 7. Less than 7 is considered as a defect. You calculate your data. What you need to calculate, you already have the minimum expectation, which is your lower specification limit, because anything higher is better. So whenever your specification higher is better, then we calculate against the lower specification limit. Looking at this, if I want to calculate what is my mean value or the average of my customer satisfaction, then my average customer satisfaction is approximately is coming 7.87. So my average customer satisfaction is greater than my target, which means my sigma will be positive. Looking at the variability in this data, which we measure in the standard deviation format. So variation of this data is 1.42 standard deviation. So the formula we use when your specification higher is better, then sigma of any process will be calculating your mean value minus lower specification divided by standard deviation. This is the formula will be used when your higher is better. Putting all these values in this formula, so my sigma will be mean value I have 7.87 minus specification lower side is 7, bracket close, and divide by standard deviation, then it's a 1.42. So this value 0.60 is your sigma level, and when we calculate this sigma will be calculated long term. I will explain you long term and short term sigma, how, what is the difference, how do we see this in my upcoming sessions. But as of now, remember, whenever you calculate any sigma level by formula, all the formulas are designed to calculate always long term. So when your sigma is 0.61, what does it mean? This means if you want to convert this into the yield percentage, then sigma to yield, there is a formula in Excel, which is the normal distribution formula, where you select norm as dist and you select your z value. Z value is nothing but your sigma level. This will give you around 0.72, which means 72%. This indicates that as per your data, what you have collected for 25 samples against the target of minimum 7, there is a 72.86% chance then you will meet the specification of 7, which means what are the chance of the defect percentage? So the number of time you will miss your SLA, if your target is minimum 7, then around 27.14 time you will miss the SLA out of 100, or 27.14%. When you have the defect, if you want to convert this into the DPMO, so defect multiplied by million, million means 10 power raised to 6. This value around 2,71,351 will become your defect per million opportunities. So this is the way we calculate our sigma level. We convert sigma into the yield, convert yield, 1 minus yield is defect, and defect multiplied by 10 power raised to 6 is your defect per million opportunity. So let's understand practically how in the graphically this value should look like. As I say, my specification is ranging from 1 to 10. Assuming, as per what data we have taken, is the minimum value your satisfaction is 0 and going up to 10. Let's say here I'm marking 0. Where the target value, what you are looking for, you are looking for 7 as in target. So this if is your average value, is the 7. I'm just putting it here. So how much data is more than the average? Your 72% data is more than the average, correct, as per this value. So how the graph will look like? Graph is inclined to the 72%, which means minimum value is 7. So more data, 72% will be of that. If I try to put a graph here, so suppose my value start from here, maybe I generated from 5. This value will go here, and this data will come like this. And you can clearly see out of this data, your average value target is 7, where the average value is coming 7.87, which means your actual average is somewhere here. I am presenting this actual average in the form of green color, and the data outside the green color, which means area, this area is outside the specification, total outside the orange line, because orange line is your target. So how much data outside the orange line is, which how much is the data outside the target line is, starting from this to this area, is your total 72.86%. And the data which is less than your target, this area, this is around 27.14%, and basis on this, what sigma value we got using in this formula, which is indicating 72.86% of your data meeting the specification. So this is the way we calculate the sigma level, convert into the yield percentage, convert into the defect, convert into the DPMO when your specification is one-sided and specification is higher is better, which means you have the lower specification value. And in this example, lower value we have indicated on a scale of 1 to 10, minimum 7 is the expectation. This is the way we calculate. Right. Thank you so much. And I'll see you in the next session soon.